Hey guys, Travis Gillespie here. We've been working with converting metric units, and let's just get that on the screen real quick. And in those videos you learned there's a mnemonic that can be used to help you convert through the metric system. The one I use is King Henry died by drinking chocolate milk. So King, capital K, Henry, died by drinking chocolate milk. And these first letters within that mnemonic are actually the prefixes for metric units. So let's actually go ahead and write that out real quick. K is for kilo, K-I-L-O. H is for hecto, H-E-C-T-O. D is for deca, D-E-K-A. B is our base units. We'll look at those in a second. D is for deci, D-E-C-I. C is for centi, C-E-N-T-I. And M is for milli, M-I-L-L-I. Let's go ahead and look at our base units first. So our base units can be written as grams, G for grams, M for meters, and capital L for liters. Well, depending on what types of measurements I'm using or what units I'm measuring in, I can use the prefixes to actually make abbreviations here. So let's start with kilo. And if I were measuring in grams, well, I would have a kilogram. Let's change colors real quick. And I would have capital K, G is my abbreviation for kilogram, capital K, little m for kilometer, capital K, capital L for kiloliter. Let's move over to hecto, changing colors again. So this time, if we're measuring in grams, well, we'd have hectograms, so little h, little g, HM for hectometer, and H capital L for hectoliter. So let's change colors. We'll move over to deca now, and this abbreviation actually has DA, and then I'd connect it with the units I'm measuring in. So DAG for grams, DAM for meters, and DA capital L for liters. Let's move over to deci. Well, this is just abbreviated as DG, DM, or D capital L. Let's change colors again. For centi, now we have CG, CM, and CL. And finally, milli, well, we have little m, little g for milligram, little m for millimeter, and little m, big L for milliliter. I'm going to make one statement here. In some textbooks, or actually in some classrooms, you might see your teacher use a little m and then a big L, and sometimes they might interchange and use a little m and a little l. Regardless of which type they're using, both the capital L and the lowercase l, they still mean milliliters here. Well, to keep this table nice and neat and clean, I'm just going to stick with the big L, capital L for now, and I'm going to erase the other one here. Now this table comes in handy when converting through the metric system. The only downside to it is you might have to spend a minute or two creating the table if you like the table, or as long as you remember that mnemonic, King Henry died by drinking chocolate milk, you're going to be okay. This isn't the only method that's used to solve or convert throughout the metric system, but it is one that comes in handy, and we'll look at some of the other ones later. Before we actually look at solving problems, I'm just going to grab a new pen, and I actually want to look at our prefixes for 1 second. Deca means 10. So deca, it's 10 times larger than the base unit. Notice I'm talking about the units, not the actual values that we get by making measurements. Just deca means that these units are 10 times larger than the base set of units. Well, hecto, it means 100. It's 10 times larger than the deca set of units, or it is times 10 times 10, so 2 multiples of 10, or 100 times larger than the base set of units. So I'm going to say that it is 100 times larger than the base set of units. Well, kilo means 1,000. It is 10 times larger than the hecto set of units, 100 times larger than the deca set of units, 1,000 times larger than the base set of units. And how did we get that? Well, times 10, times 10, times 10. That's 3 multiples of 10. So I'm going to write times 1,000 here, and not times 1,000. It's 1,000 times larger than the base set of units. I think this is a good time to note I'm not telling you to multiply by 10, multiply by 100, or multiply by 1,000. I'm just making a note these are 10 times larger than one another, or in the case of hecto, it's 100 times larger than the base unit. Kilo is 1,000 times larger than the base unit. This looks like a good time to note. If you're going to convert metric units and move to the left throughout the metric system, the units are actually getting larger as you move to the left. So deca, hecto, kilo get larger as you move along throughout the metric system to the left. Well, that must mean if you're going to convert metric units but move to the right throughout the metric system, well, that means that the units must be getting smaller. So deci, centi, milli should be getting smaller. Let's make those notes real quick. So the units get larger as you move to the left, and that L with the circle represents left, and the units get smaller as you move to the right throughout the metric system. Notice I'm talking about the units, deca, hecto, kilo, deci, centi, milli. I'm not talking about the values we get from our measurements. So let's go back to our base unit real quick, and I'll change pens. Well, that must mean that deci is 10 times smaller than the base set of units. Centi has to be 100 times smaller than the base set of units. Write 100 down there, 100 times smaller. And milli has to be 1,000 times smaller than the base set of units. Let's fix that multiplication symbol real quick. Okay, so if the units are increasing in size by multiples of 10 as you move to the left throughout the metric system, well, let's take another look here. Well, deca is 10 times larger than the base set of units. That's 10 to the first power. Hecto, 100 times larger, is 10 to the second power. And kilo, 1,000 times larger, is 10 to the third power. Now let's actually move to the base set of units now, starting from 10 to the third power. Well, we have 10 to the third, we're getting smaller, 10 to the second, 10 to the first. The base set of units has to be 10 to the power of 0. Well, I can't have 10 to the first power here, so I have to have 10 to the power of negative 1. For centi, it would be 10 to the power of negative 2, and milli is 10 to the power of negative 3. Okay, well, this is probably more than you'll ever need to know or want to know in middle school math, so in a future video I'll show you how just to set up the table only to help you convert through metric units. Okay, well, before we head out, let's just solve one problem to see how this table can help us out. So pretend that you made a measurement, and whatever the measurement was, it was 2.34 meters in length. And you want to convert this measurement to centimeters, so I'm just going to put cm here. Well, the first thing you need to do is locate that first set of units within your table here. Be real careful because I have meters here, that m represents meters, but there's a little m up top. And this little m does not represent the set of units for meters, it represents the set of units for milli. So where is that little m within this table? Well, that little m is right here under the base set of units. So this m represents meters. Well, I've got to ask myself, how do I get from meters over to centimeters? And in fact, ask myself, in what direction am I traveling? Well, I'm moving to the right, and I'm moving 2 units to the right. Well, the simple trick here is go down to the decimal in your problem and move it 2 units to the right. So 2.34 meters is equivalent to 234 centimeters, and that would be the answer to that problem. We're going to take a look at solving a few more problems using this table in the next video.